Now we're looking at R2.9, solving systems of equations. So there are three techniques. The first one we're going to look at is the graphing technique. If you're going to solve a system graphically, you want to graph the two equations and look for the intersection. Any point that satisfies all the equations is going to be the intersection. Okay, so graph these. The bottom line I can graph right away because it's already in y equals mx plus b form. So the y-intercept is 2 and the slope is 1/2. So up 1 over 2, I can get a whole bunch of points for this real quickly. And then down 1, back 2 as well. And I don't have a ruler. Let's hope I can connect these in a straight line. I hope that you have a ruler or a straight edge you can use. My camera's kind of resting over my arm right now, so I can't get up. But there we go. I got my line. And the other line, so that was this first one. And then the other line I'm going to use a different color for, and I need to solve for y first. So we'll do this one down here. And I need to solve for y, so I'm going to rewrite and then subtract the 3x from both sides. That 2y is positive, that 3x coming over is negative, that 4 is still negative, and then we're going to divide by 2. I can write the whole thing divided by 2, or I can go ahead and distribute that division so both parts are divided by 2. So I have negative 3/2, pull the x off to the side, minus 2. Now that it's in y equals mx plus b form, slope is negative 3/2, y-intercept at negative 2, I can go down 3 over 2, and down 3 over 2, get some points, or I can go up 3, back 2, I'm going to use that point again, up 3, back 2, count up 3, back 2, and let's see if I can draw this. Apologize, I gotta tip my paper so that I can draw this line correctly. Alright. So, the intersection is going to be the solution. So my solution fell, luckily, in a whole ordered pair right here at negative 2, 1. Right. So graphing is one effective technique for finding the solution. Unfortunately, there are a few problems with it. One, if your graph isn't precise, you might not get to the true intersection. Or two, if it doesn't intersect a whole ordered pair, whole numbered ordered pair, it might be very hard to estimate a solution by graphic. So we have two other techniques that we're going to see in the next 2 pages. Again, this is a review, so you've probably already seen them at some point. We're just refreshing our minds here. One of the next techniques is substitution. The substitution method relies on solving for either variable first, one of the variables, whichever is easier, and then substituting that variable into the opposite equation. So solve for one of the variables first, substitute. I look for an easy target, a variable whose coefficient is 1, and in this case, my easy target is that second x because it has coefficient 1. So let's solve for that one. So I'm going to add the 2y to the other side. That will give me x equals 2y minus 7. Then in the other equation, it was 3x plus 4y equals 9, but we're going to replace x with what we now know x is equal to. So we will have 3 times 2y minus 7 plus 4y equals 9. Distribute. 3 times 2 is 6y, minus 3 times 7 is 21, plus 4y equals 9. You got like terms, add your y's, 10y, minus 21 equals 9, add your 21. 9 plus 21 is 30, divide off the 10, y value of 3. Once you have your y value of 3, back over to the other equation to find the x value. X is equal to 2 times y, 2 times 3, minus 7. That's 6 minus 7, or negative 1. So just like that, we can find the solution. It's an ordered pair, so I need my x and my y value, and the solution is negative 1, 3. That did the same thing as graphing did. We just did it a different way using the method of substitution. Find the intersection between those two lines. Sometimes it's not possible, or there is no variable that's easy to solve for, like this one was because it had coefficient 1. in which case you'll use the third method, which is elimination. Elimination relies on least common multiples. So we're going to choose and eliminate the variable with the lowest least common multiple and multiply whatever it takes to get that variable to have the same common multiple in both equations, then add the equations together. So for example, if I look at my x's, the least common multiple is 6 because 2 and 3 both go to 6. If I look at my y's, the least common multiple is going to be 20 because 5 and 4 both go to 20. So we're going to want to choose the x's to work with here just because the numbers will remain smaller. Okay, so I'm just going to rewrite the two equations. 2x minus 5y equals negative 18, and 3x plus 4y equals negative 4. My goal is to multiply to 6 for my x coefficient. Now, I actually need one 6 and one negative 6 so that they're opposites of each other. So to make a 6, I need to multiply the top equation by 3. To make a 6, I need to multiply the bottom equation by 2. That makes two 6's, not opposite, so I need a negative 2. I want one 6 and one negative 6. All right, so 3 times 2, that's 6x, minus 3 times 5 is 15y, equals 3 times 18, which is 54, negative 54. So make sure when you're multiplying that you're multiplying both sides of the equation, so we're going to distribute that all the way across. Okay. Negative 2 times 3, that's negative 6x, negative 2 times 4, negative 8y, and negative 2 times negative 4, positive 8. Okay. Steps 3 says add the two equations together. Adding them together is going to eliminate the 6x's because they add to 0, and then the negative 15y minus the 8y is going to add to negative 23y, and the negative 54 plus 8 is going to add to negative 46. We can divide both sides by negative 23. Negative 23 goes into 46, so we get a y value of positive 2. Once you have one value, use any of the originals to substitute that back in. So the top equation is fine, we'll use that one. So I have 2x minus 5 times the y value of 2 equals negative 18. That's 2x minus 10 equals negative 18. Add that 10 to both sides. 2x equals negative 8. And if I divide both sides by 2, I'm going to get that x value as negative 4. Don't forget your solution needs to be in ordered pair. So x value first, negative 4, comma y value, which is 2.